We'd like to use the bonus week as an opportunity to present what we've wanted to say. How did they set up vehicles at the Benz Museum? The first method is to insert permanent goods lift, but it takes up a lot of space. It is also not suitable because it is a characteristic of the Benz Museum's exhibition hall, requiring 3 to be located in each core. Other methods must be considered accordingly. So the method is to use a vehicle crane inside. The inner crane comes down from the bridge. If you look at tower crane, the counterweight helps to balance the load when the crane is performing a lift effectively. The law of counterweight at the Benz Museum is 3 cores. The bridge connecting trefoil also serves as a seat. The crane, which came down from the top of the atrium, is gravity downward, so it needs a lift technology to go up. It operates in tandem with a hydraulic lifting platform located outside at the rear wall of the museum. The advantages of a hydraulic system include the ease and accuracy by which they can be controlled. Also, because the winch gear is on the 8th floor, it is not possible to put the vehicle on the 8th floor with an internal crane. Therefore, the 8th story exhibition used an external crane. As a result, the vehicle is moved from 1st to 7th floors using an internal crane, and to 8th floors with an external crane. Usually, when you look at the exhibit, it's hard to look at the bottom or the top of the car. But to view the exhibit from all sides, the Mercedes-Benz Museum designed a variety of void spaces. This also many users to look at the exhibit from various angles. The lighting is essential to highlight displayed vehicles to the audience. Light is one of the main factors in determining the atmosphere of space. Natural lighting is required that fully reveals the value of the exhibit, not just the amount and brightness of light. The Mercedes-Benz Museum harmonized natural and artificial lighting. It also provides a beautiful exterior without colorful exterior lighting. As the first step in installing this light, they tested the balance of natural and artificial lighting in space. Through computer simulations. As a result, the location of artificial lighting in the building is determined. and designs were made considering the type and direction of lighting depending on the space. To see the balance of natural and artificial lighting, they selected a certain part of the building. And after making a model, they tested how light came in if you look closely inside the building. You can see the light entering the model interior, which can be compared to the actual light. So the Benz Museum used artificial lighting to emphasize details as well as the use of the natural lighting. Exhibition space is divided into a legend room and a collection room. The legend room is covered with aluminum panels which prevents natural lighting, while the collection room receives natural lighting through the surrounding grass. The legend room uses different artificial lighting on each floor to aim spotlight on the highly reflective car surfaces. To create a natural and soft light in the collection room, they developed a special ceiling that incorporates sunken, bubble-shaped light. The interior light angle can be rotated 340 degrees perpendicular and 180 degrees horizontal, showing the exhibit more effectively. They predicted that indoor thermal loss were caused by lighting, and they needed to be sure. Therefore, the air conditioning components for the museum were designed using extensive thermal and flow simulations, and selected. The analysis showed that the main part of the indoor thermal loss is caused by the exhibit and room staging light. Also, they considered the characteristics of the Mercedes-Benz Museum. There are two principal different areas that are treated similarly in terms of ventilation and air conditioning. It is dark and unglazed legend rooms, and it is the collection room with glass facade. The change in the glazing coating from 50 by 25 to 66 by 33 requested by the client had a major impact on the external thermal loss in the collection area. Several thousand visitors per day bring a great deal of heat and moisture into the building. Given this consideration, they used distributed fan coil system. Unlike conventional fan ventilation, it establishes new benchmarks in terms of smoke emission efficiency, cooling capacity, noise improvement, and convenience. Ventilate the air from the central layer to the decentralized fan coil system for vehicle preservation and people's comfort. Fresh outside air is supplied through 25 plastic pipes connected to the air duct on the legend room lamp. This pipe is made of concrete on the outer wall. The distributed coil system provides a high-quality ventilation system. Normal operation is 2,500 cubic meters and 7,500 cubic meters of air is circulated in the center floor per 700 cubic meters of exhibition space. The central atrium serves as a light main vent and chimney to release air from the entire building. In addition, some solar benefits and natural lighting are also regulated. The 40-meter high atrium is an open space connected to all exhibition halls. What happens if a fire breaks out in this high and large space? The fire will continue to spread everywhere, and smoke will cover the entire building in a short time. Therefore, it causes a fatal situation. The central atrium, which acts as a chimney, is the point where artificial tornadoes occurs in an emergency, when earth smoke can be discharged upward. When a certain amount of smoke occurs, the sensor reacts. There occurs smoke and RWA system, that is a computer simulation and testing based impact that create the museum's fire protection concept, causing the air nozzle to create a cyclone vortex due to a fire and extracting about 250,000 cubic meters per hour of smoke to the outside. Today we focused on system. Next, we will be studying the 7th part, Construction 3. Stay our reference. Thank you for listening.